We are going to hear from Chris Withers on things to make writing tests easier. Please give him a warm welcome.
Right, good morning. Sounds like you guys can hear me. So if we're going to talk about testing, we probably want something to test. This is a nice, simple little thing that might come up, nice and unit testable. So we've got a CSV full of data. The requirement comes in saying, pass it, tell me who owes me the most money. So we're going to start off with a little stub function and a stub unit test to go with it. And we've now got the framework that we're working to. I like to do test-driven development, so this is kind of where I would start off. Our next step from there is going to be to actually write a real unit test. This might look a little different than some people would expect. If you're doing testing with CSVs, you might say, why not use CSVlib to write your test CSVs? Well, what about malformed CSVs? What about white space where you're not expecting all these kind of things? So looking at what we've got here, take a name temporary file, write some stuff to it, call our function, check we get what we expect. We even have a little implementation here. Again, test-driven development-wise, so this is the simplest thing that will work and pass all our tests. It has some obvious problems, I'm sure you can see. It'll just basically return the first name in the file. So if we round this out and provide some more tests, we now have a test which actually tests our real functionality. If we go through and say, well, what happens if we have some Unicode in there? Do we get the name correctly formatted? Just as an aside, we're going through using name temporary file here. This won't actually work on Windows. And this is one of the reasons why we'll come to the test fixtures way of doing stuff. If you try and reopen a name temporary file on Windows, it'll say, I'm sorry, someone else is already using that. Too bad. So moving on, another little test. This time we're checking when we've got white space in our data, we do the right thing. We still, we get the name back. It doesn't have the white space on it, and we still manage to parse our money owed correctly. So if we have a look at the implementation, it'll actually get all those tests to pass. It's fairly nice and clean, but there's still some bits and pieces which we are worrying about there, as you can see in the comments. So what happens if we can't create the number correctly? And if you remember on the first slide for the implementation, was like, we want to know how long this took. So this is sort of nice test data, which is very simple. If we had a 10 gigabyte CSV, maybe we care a bit more about how long that's taking. So let's add some more tests just to care about the bits we care about that we haven't done yet. We've got a nice invalid number there. And we've got a completely malformed CSV here. Now this is sort of a pattern people who've tried to write tests for exceptions might have bumped into before, and certainly back in Python 2.5 and 2.6, you end up with situations where you say, well, I need to catch the exception and then make some assertions about it, and then if there's no exception, I need to raise, sort of fail some other way. You end up, that's quite a chunk of code just to say, well, did we raise the right exception? So now we actually have the code which sort of finally passes all our tests. But there's some bits and pieces in there we're still kind of worry about. Well, we've got this, we now have some implementation for how long did this take. We don't have any testing for it. And testing the kind of stuff that's untested still here is stuff that I don't see many people doing, mainly because it's really hard and for not much benefit. Logging, well, yeah, if it works, it's great. If it doesn't, well, such is life. That is fine up until it's 2 o'clock in the morning and you get a log message via a page or something which doesn't tell you the information you needed to solve the problem. For that reason, I kind of came back and went, well, I'd really like to test that logging, which we'll come on to in a bit. The other problem we've got is if we now run the test, you get that kind of output, which is not ideal. I don't know about you guys, but I like to see dots when I run tests. I don't like to see anything else. I think it makes it much more confusing if you have other outputs interspersed in there if it's supposed to be okay. Is that okay output, or does that mean something's gone wrong? Who knows? Well, we can shut that out by sort of in our tests getting hold of the logger and putting a really high log level in so that nothing gets logged. But that's not ideal. What's this? Yeah, there we go. Is that better? Cool. I'm not rustling anymore. I'm sorry for that. However, so we've tested a relatively small amount of functionality, but we've ended up with quite a lot of code here. There's quite a lot of duplication, and we're software engineers, duplication is bad, right? So what do you do if you have duplication in your tests? Well, you factor it out. Well, but then you factored those things out. Shouldn't the stuff that you factored out now then have tests of its own? And then you kind of sort of recurse down this rabbit hole of will that stuff then need tests? So my take on this was to actually start collecting the bits and pieces that I used every time I wrote tests, document them and write tests for them and put them in a package. So hopefully, using that, we'll take those tests and shrink them a bit. That doesn't look like it's significantly shorter, but there's also some stuff being tested in there which we haven't been testing up until this point. So those are the bits and pieces we've added. These are a bunch of stuff that comes from this package that I'm going to be talking about. And using those, we've got rid of all the boilerplate for writing stuff, which we'll go into in more detail later. We can now make assertions about the logging that's been done to actually check that it's correct. You'll notice it has a time in there that's not insane and doesn't have little points at the end of it. It's because we've mocked out time, if anyone noticed in there. And then down at the bottom, we're also saying, you know, we're checking that we logged our exception correctly, but nothing blew up. We've also checked, I don't know if you see down the bottom there, we can check that when an exception is being raised, actually the correct exception is being raised with an error message that is useful to us. So coming on to this stuff, a lot of the bits and pieces I'll be talking about and the stuff that exists in test fixtures have ended up in the standard library. I think around Python 3.3 is when you get all this stuff. That is a challenge for me because while I'd like to be using Python 3 for everything I do, the majority of the stuff I do is spread between maybe all the way back to 2.5 sometimes. Majority is 2.6 and 2.7. And then if I'm lucky and it's new stuff, Python 3. For that reason, I like to use libraries to provide the stuff that we're going to be talking about here because I can use those same libraries across all the versions of Python I play with. Test fixtures is the one that I maintain, and so I'll be talking about the most. We'll cover briefly Michael Ford's excellent mock library. I thoroughly recommend you read the documentation for that. It will end up in the standard lib, I believe, as of Python 3.4, which is great. So that's a nice, good bit of information. There's also unit test 2, which just brings some of the stuff from newer versions of Python's unit test library to other versions of Python where you want them. So anyway, diving in this kind of stuff. One of the most common things we do in tests is we make assertions about stuff that's happened or conditions that we'd like to be. This used to be pretty poor, and in fact, if there's a really nasty pattern I see of people using assert something equals something else, which basically when it fails will give you a true or false answer depending on which round you did it, and no feedback as to what that meant or what you were expecting. I don't like that much, so I wrote what initially started off as a nice simple function called compare. This will raise an assertion error if you give it two values that are not equal, and will do nothing if they are equal. However, where it starts getting interesting is where you start looking at what that information comes back at looking like when you get a comparison failure. So a simple example at the bottom there is strings. They actually line up for you, so you can say, oh, okay, that's where they differ. Long strings, you get a diff, which is pretty handy if you're doing like comparing output from a file or dumping a CSV or something like that. You'll say, okay, this is the stuff that's different. There are actually options to show you the white space differences there if you start caring, and you really do care when they don't match up and you can't figure out why. Sets, you'll get a nice little example of, well, what's the difference between these two sets? Not so much of a problem when they've got two elements. When they've got 30 or 40 elements and 28 or 38 of them are the same, it's quite handy to have something to just say, well, these are the ones that didn't match up. So have a bit more information. Likewise with dictionaries, very similar to sets, but it will say, okay, you're missing these keys, and for these values didn't match up as well. Lists and sequences, again, we can rattle through these pretty quickly. It's just when stuff doesn't match up, give you really good feedback. However, the next thing you hit is that not all objects will support comparison. Now, some people would say just give them a comparison method. It makes your testing easier. It's a good idea, right? Well, not necessarily. Why would you have this extra code if it's only there for testing? The flip side of that is that sometimes, like Django models, I'm not sure whether it's still the case. It certainly was the case when I last bumped into them. You get comparison whether you want it or not. So you'll have a comparison function implemented on the object you're trying to test, which means that you can't say, have I got the same objects, because they'll do the wrong thing. So to help with some of these things, test fixtures has some little helpers in it. There is a thing called generator, which will give you, it just gives its arguments as a generator. It'll yield them off, so it's a very quick way of getting a simple generator to test with. You'll then notice with compare, if you do an assert equals, you will basically just be comparing the IDs in memory. So they'll never compare equal, even though they might unwind to the same thing. If you're actually unwinding generators, if it's important that it was a generator, as in you're doing something where you want to make an assertion that basically says, I wanted a generator, make sure I got one. If you just unwind those into a tuple, you don't know whether the thing that you're testing just returned a list or whether it's actually implemented properly as a generator. With compare, when it sees generators either sides, you'll get basically, it will unwind them for you, but it will also make sure that they're the types you expect. and again, give you great feedback. This is one that I'm reticent to talk about, but it is very handy. This is a string comparison object, which I tend to import as S. Creates something that behaves much like a string, except when you compare it with another string, it actually does a regex comparison. So where this is really helpful is where you've got things like thread IDs and process IDs, where you basically just want a number in there, and you're not going to know what that number is. There's no way in your test you're going to know what that number is. So just say, look, I want my number there. The problem with this, and why I say use really sparingly, is these are regexes. Ned Batchelder collected a really good set of jokes around, I had a problem, so I decided to use regexes to solve it. Now I have 2 problems. Google 2 problems Ned Batchelder for the full list of very good jokes on that front. So they're useful in moderation, but just don't dive on them as your first thing. Coming back to our objects that don't support comparison, in the same way as we had the string comparison object, also, and this one I use much more frequently, we have a comparison object here which I generally import as C. This will let you compare with things. It's kind of important that it's the first object, so it's always on the left, because that means its comparison gets called first and the other object's comparison doesn't get a chance to screw things up, basically. Using this, as you can see in the examples there, you can make assertions that basically say, have I got something of this class, either using a dotted name or actually just using the class if you happen to have it imported. Or you can make more complete assertions by saying, look, have I got an object of some class which has these attributes and these values? The nice thing is that with these comparison objects, when something doesn't work, they collect information about what didn't work. So your assertion error there, you'll see it says, OK, this failed. X was 2 when we expected it to be 1, or sorry, it was 1 when we expected it to be 2, and Y wasn't in there at all. That makes life a lot easier when you're looking at objects that are potentially opaque from the outside. But you may not want to compare all attributes. Something like a SQL Alchemy object instance has an attribute which you really don't care about, which is just all the internal state. I quite often will use a comparison with those kind of objects and just say, compare the attributes I care about and know about, strict equals false, don't tell me about the rest. Winding back again to compare, this is something that has ended up again in the standard library, this time a little bit earlier. So if you're in Python 3.1, you're in luck, and you can start adding your own functions to do comparison and give you useful output. With test fixtures, I hit this first myself using name tuples, which is why the example's here. These are not, they're their own type, so it's very difficult for the type introspection stuff to figure out. But if you're doing a lot of these, say if you have code that returns, you've got 30 or 40 tests that all work with the same name tuples. Being able to register that type with compare sequence and just say, look, these are tuples, can you just tell me what elements are different, is great, and you get the same nice feedback. However, sometimes the type is important, and again, this is I hit most commonly with name tuples, where if you have 2 name tuples and they have the same, they're the same length and they have the same contents, they'll compare as equal, but it might actually be quite important to your application that those are not of the same type. Compare has a strict mode for that, which will basically make sure that not only do they feel the same, duck type-wise, but they're actually directly the same type. If that fails, you again get good feedback saying, look, we're expecting an A, and we got a B. This is something that actually came out really recently, and I was surprised it hasn't cropped up anywhere else. We've got all this wonderful rich comparison, and again, in the standard library now as of 3.3, we have the same rich comparison. That's often not enough. If you see a big run of test failures, and somewhere in the middle of that is a 1 not equal to 2, it's like, well, what does that mean? What is that 1? What is the 2? Being able to just add a small piece of text to give you a little bit of context as something flies by, in this case, wrong number of orders, is a nice, simple way of dealing with that. This will work with all the previous rich examples we've seen, so you still get the nice, rich context feedback when stuff fails, but a little bit more that you can add yourself. Moving on from compare, lots of code, especially old code, tends to have print statements or nowadays print functions littered throughout it. Not only does that make your test output crappy when you're trying to start off with things, again, same as we said, you don't get the dots, you get lots of stuff stuck in there that you don't really know about or care about. And of course, sometimes that output's actually important and we want to test it. Test fixtures has an output capture context manager. I firmly agree with Raymond's comment this morning that I think context managers are going to be quite a game changer for Python as stuff goes on. In this case, we're just saying, look, for the duration of this function, I just want to take all output and capture it. It'll capture stderr and stdout, put in a string, and let you make assertions about it. For ease of use, the white space is stripped off both the actual and expected results, but the full original text is captured in a captured attribute that you can go and have a look at. With exceptions, again, this is one that is solved 3.1 onwards in the standard library. But I don't have the benefit of being able to use 3.1 most of the time. I think most test helper libraries have a context manager now which deals with raising exceptions. In test fixtures, this should raise. So if you're being lazy, you can just say, well, I expect this to raise an exception. That's not great. Where the standard library tends to go is to say, well, I want an exception of a certain type, which I personally still think is not great because I've had one too many times where I've raised an exception, and when I've really needed that information at 2 o'clock in the morning, I've got the format string wrong or something like that. And it's kind of like, great, well, now I don't have the information that I needed. I need to go back and try and reproduce the problem without really knowing what happened. So my preferred way of dealing with this is actually the third example there, to say, this should raise this exception with these with these arguments. And if that's, if you go that far, you're probably going to get what you expect. And again, the context manager does have an attribute which is the exception that was raised if you want to go and make assertions about specific things if you have exceptions that are stateful. Okay, this is onto one that I think will probably be one of the most useful ones for people here. It's a helper called temp directory, and it just wraps up all the things that I've needed for testing to do with files and directories in quick, succinct statements rather than having to do, context managers, making temporary directories, and managing all that kind of state yourself. What you end up with, most of my test suites that people look at will find a self.dir equals temp directory in the setup, and a self.dir.cleanup in the teardown. Those dir objects can also be used as context managers if you're just doing something small that uses some test files. But the important thing for me is that the primitives are provided by that object are nice and simple to use. So if you want to write a file, you say the name of the file you want, the data you want to be written into it. Python 3, that's got to be bytes, unless you give it a string, in which case you can give it an encoding and say, write this to disk in the way I've asked you to. As far as the paths go, irrespective of operating system, and this is quite an important one for me, you can either pass in a tuple of path segments or just a / separated path, and that will work no matter where you use it. In the case of paths like that, if the intermediary folders do not exist, they'll be created for you. Just again, nice little stuff to make life easier, make your test code smaller and easier to show what you're doing. Okay, but if it's your test that's actually writing the data, you might want a path that doesn't exist. It might be important for you to test that your code makes the intermediary directories, for example. So the getPath method will give you just a path that's rooted inside the temporary directory that's been created for you, but it won't exist, and it's up to you to do that. Again, quite often you'll have code that, now that you've finished writing your data, you want to make assertions that you've written the correct stuff to disk. The read primitive, nice and simple way of doing that. If you know you're reading text in a specific encoding, pass the encoding in, it'll be decoded, and you'll get Unicode back. As you might expect, a lot of code sometimes needs particular directory structures, and you might be parsing a directory structure, and how your code behaves depends on what the directory structure is that it finds on disk. Nice, simple ways to make directories using pretty much the same pattern we've already seen. You can give it a / separated path, or you can give it a tuple of path segments. It will create that stuff for you. Also nice is the ability to make assertions about the contents of a particular directory. So checkdir just does a one-level check. So if there was a subdirectory in there, you could still assert that it existed, but you wouldn't make any assertions about its contents. If you do want to compare the whole way down, this example here is for comparing the entire contents of the temp directory. That first parameter to check all is actually the place to start checking from. So if you only want to check a subdirectory, say if we only wanted to check the user folder, we would pass in root/user folder as the first argument. The rest of it is the expected results. You'll notice folders end up with a slash on there. It's so you can make sure that an empty folder exists. These checks are always stable ordered, and they work the same no matter what platform you're on. That sounds like a triviality, but it's really annoying. Things like locale ordering on different unices can really screw you up if you write a test and then move it to a different operating system and suddenly find it doesn't work anymore. And you can configure temp directories to ignore certain names, like, for example, .svn directories is quite a handy one. Okay, the other big one, which people don't tend to test, as I said, because it's too hard. Python has a great logging framework. It abstracts away where your log entries go from where you generate them. But you most often want to check that your generation is done correctly. there is a nice, well, so here's some code, for example. A nice helper is the log capture helper, where you basically, again, it's a context manager, or you can use it in the manual fashion in the setup and teardown like we did with the temp directory. Fire off some code that does some logging and check that that logging is done correctly. It'll make sure that no other handlers get harmed during your logging. It'll remove them out of the way and set the level down to a point where you can capture the logging. And you can make some quite detailed assertions about the log entries if you want, because the log entries themselves are actually recorded for you. So you can say, if an exception was logged, as in that example, we can go and check that the actual exception object raised was the one logged was the one we expected. And there's some other bits and pieces about capturing at certain levels and certain loggers. This is all pretty well documented. Again, it's something I was very passionate about with test fixtures, of making sure that everything is documented. It's not on read the docs. I was unfortunately early enough on read the docs that my account broke, and I just haven't had a chance to fix it. So it's now on. It's still on packages.python.org, which I believe is pythonhosted.org now. I think that changed recently. Okay, so and you can also uninstall and reinstall these capture devices as and when you want. So if you've got a piece of code which you know is going to spam some messages you don't care about, you can just leave it off for that point. Something else that's kind of important that people don't think about is if you have configuration code in your application, it's probably good to test that that configuration code works correctly. In our case here, the configuration call is just logging.basicconfig. But it's kind of, the setup is harder for doing this kind of stuff because you need to actually get all the existing handlers out of the way. But then once you've done that, you can make some assertions that you've configured your logger with the correct level. And this, heavily using the comparison objects we see earlier, is making sure that the handlers we've configured in our configuration code are actually there as we expected. Okay, moving on quickly. I haven't got much time, so I'm going to kind of skip through some bits and pieces of this. Mocking is something that in Python you have to be careful. If you're inserting a mock object, you need to insert it in the right place. If you've imported a module like datetimes DT, you only need to replace the thing you'll want to mock out in that module. If you've done what some people see as a more common pattern of from module import a name, everywhere that has been done, you have to go and replace that name. That's just a little aside. Most people will probably end up using mock's patch decorator because it will be in the standard library as of 3.4. I have my own one because mock didn't exist when I started doing this. And that will let you do basically dotted name replacements. I tend to use mocks for that. With this example, you can see some of the assertions you can start making with mocks. And it also lets you do some stuff which mock's patch method does not let you do, such as replacing out dictionary keys, removing whole dictionaries, or removing attributes from objects. This is the keys and dictionaries one is particularly helpful if you're doing stuff that processes off.environment, for example, is making sure that an environment key is there or not there. As a quick example, things that might be there, this is some quite interesting code. It behaves differently depending on whether the Guppy library is available or not. So we want to make sure that we call the Guppy library correctly, even if we don't have it there when we're running our tests. There's some other bits and pieces I want to get onto, and I'm aware I'm quite short of time, so I'm going to skip through this. But just have a quick look at that slide and see it makes assertions about the calls that are made while making sure that the library appears to be there. The last bits and pieces I want to show you, these are mocks that I find very useful for doing dates and times. If you care about how long things take and what the times are, you don't really want to have to rely on your system clock. You want to be able to sort of stub stuff out. So these mocks, there are one's for date time, one for date, and one for time itself, and they will let you say, let you specify either just give me some dates and times, give me some specific dates and times the next time I call you, or actually can you just have a delta between the dates and times every time I call you, so things are going on, this one will give you intervals of 2 hours. So the datetime mock, I should say, has very good support for time zones. I'm not going to go into that because time zones are horrible and worthy of hours of discussion of their own, but the support is there and quite well documented. These are the examples for dates. Same kind of thing. Add some dates that are going to be returned, set a specific date and a delta. And finally, times. So people don't call time that often now, but most often it's for sort of, well, how long has it taken to do this? Are we over the threshold? And again, this lets you basically give the same sort of date time arguments while still getting back the floating point times. And again, a delta of 0.5 seconds this time every time we call it. I'm going to skip there to questions, because I think we're probably just about out of time, right? So thank you very much.
If you have any questions, please line up behind that microphone over there.
And if not, there's the details on stuff for the bits and pieces we've been talking about. Please do tweet me, email me, ask me questions. I'm more than happy to talk about this stuff. Come and find me afterwards.
So one of the things that gets me writing tests a lot is it'll say 1 does not equal 2, and I don't remember which of those values I expected and which one I got.
Yep.
And I noticed yours says first and second instead of something like got and expected. Would you think of changing that?
I kind of have made a design choice over the years, because for the comparison stuff you have to have the comparison object first. I just always do expected, actual in that order. But then other people will say they want that the other way around. So really what I'd say is, for your project, make a decision and then stick to it religiously, because it'll come back and bite you.
So like usually when I'm mocking something like a system call, like open, like I've usually pull it out into its own function, and then I call it in with all the context within the class.
Right.
And then that way I can mock it out, and I can either replace the function within the class, or just call the individual methods around it. Is there something in your mocking or in the new 3.3 mock that I can avoid doing that, or?
So I'm fairly passionate about not having to change how you style your code just to test it. Mm-hmm. So what I would say is, if you write your code like you would write your code as if you weren't going to test it, either the patch mocker or the replacer in test fixtures will let you go that you can step inside a class and do class methods that you want to replace out. Or alternatively, you can replace that stuff at a module level. If you find stuff you can't replace or that doesn't behave as you expect, and you're using a replacer, drop me an email and I'll fix it.
Okay, so it's something that your library can do, though.
Yeah, absolutely.
Okay.
Yeah. And if, as I said, then you might find situations where something's weird and you can't. I'm really interested to find out about that. So.
Okay.
Cool.
Ladies and gentlemen, Chris Withers, thank you for coming.
Thank you very much.